So we're going to look at payout annuities here. In this version, we have saved $400,000 for retirement, and we have an account that earns 4% interest. We want to be able to pull out monthly payments over 20 years. So what should that monthly payment be? And this is the idea of a payout annuity. So let's take a look at our finance formulas. And we are looking at a payout annuity, bottom row here. And we could use the calculator version or the spreadsheet version. I'm going to start off with the spreadsheet version, and then we could check with the calculator version. So the spreadsheet version, we want to use the PMT function, and we need to know the rate, and we need to know the compounding period, the number of years, the initial value, and we have all of that here. So let's see, the initial value is usually called P0, and that is $400,000. Our annual percentage rate, R, is 4%, which we want as a decimal, so 400ths. We are taking monthly payments here, so K, the number of time interactions per year, is going to be 12, and we're going to do this for 20 years. And we, according to that formula, want the PMT function. And the PMT function for the spreadsheet wants to know what's the periodic rate, wants to know the number of periods, that would be total. It wants to know the initial value. It wants to know the final value. And then it wants a 0, or we want a 0 at the end to indicate that we are having payments at the beginning of each month. So our periodic rate, well, that would be 4% split over 12 months. So that's just 0.04 over 12. So we could, in a spreadsheet, enter, PMT equals PMT parentheses 0.04 over 12, comma, the number of periods. Well, there's 20 years, 12 months per year. So that's going to be 12 times 20. The initial value, because we're moving through time, is a negative 400. 1, 2, 3. We want to zero out the count at the end of those 20 years with payments at the beginning of the month. So that formula will tell us what the monthly payment is. Let's go for a spreadsheet and give it a shot. So I'll show you how to set up a spreadsheet like this one right here. Whenever you do a spreadsheet, like when you take notes, you should indicate what each amount means. So in one cell, I say initial amount. In the next cell, I tell you what the amount is. So I have my initial amount of 400,000. My rate in this case is not going to be 8%, but 4%. I'm just going to replace that. I'm definitely doing 12 periods. So we're doing monthly periods here, but again, it's not always months. It could be yearly payments or quarterly payments. Years, this case is going to be 20. And here I have the spreadsheet with the formulas already in it. I'm just going to start over. So how do I do the PMT formula? Let's just delete that and start over. So again, equals PMT. And we want the periodic payment for an annuity investment. And again, this is a payout annuity. And it wants to know the rate. And again, when you can expand that, and it just says interest rate, and it's got to be the periodic rate, not the APR. So what's the rate per time you get money? So that would be, I'm just going to point and click on the cell where your percentage lives, divide by, click on the cell where the number of periods per year lives. So that's our periodic rate. Total number of periods, well, that would be 12 months per year times asterisk, click on the number of years. So we can just point and click here since I've already typed the numbers in. Present value, that is going to be the opposite of our initial value, comma. And here it says, because these are in square brackets, they're optional. We don't have to type them. So if we don't type a 0 for future value and a 0 for beginning, end or beginning, it's just going to assume what I had mentioned before. But I'm going to put them in just to be clear, but I'll take them out in a minute just to compare. So here I can see if I deposit, if I have $400,000 in the bank, then every month for 20 years, I can withdraw $2,423.92 if it stays at 4%. And at the end of 20 years, my money will be gone. Now, let's think about that. Total withdrawals. So let's start over there. What am I doing? Well, I'm taking this amount of money right there times 12 months per year times 20 years. That's the amount of money I'm withdrawing from the bank. So altogether from the bank, I'm withdrawing $500,000. Okay, but the catch is, right, some of the money I haven't withdrawn is collecting interest while it's hanging out. So the total interest I earned is just going to be the difference between what I started with and my total withdrawals. So over the course of this annuity, the money that's been hanging out in the bank over time, which started at 400,000 and then decreases by almost 2,500 per month, over time, I've accumulated almost $200,000 in interest on that amount, which is pretty awesome. So again, the power of interest rates and savings accounts. So again, we just determined that for an initial amount in the bank of $400,000 with an interest rate of 4%, making monthly withdrawals from that bank account for 20 years, if we withdraw $2,423.92 a month, at the end of 20 years, the account will be perfectly empty. Very cool. We could double check that with the calculator version of the formula just for fun. So let's do that. Calculator version is this bottom one right here where we have that initial amount times the periodic rate divided by parentheses 1 minus 1 plus. So I'm just going to type that in there. I guess I should write it down to be clear. So again, calculator version of this payment, and our book calls that payment D, is going to be the initial amount, so that's our P0, times the periodic rate, right, how much interest we get per month, divided by, and some calculators need that parentheses under the division, 1 minus parentheses, 1 plus that periodic rate again. The power here has to be in parentheses on most calculators, and it is negative total number of payments. So that would be K times N. Close parentheses, close parentheses. So for us, on a regular calculator, that would be 400,000 times parentheses 0.044% over 12. And then all of that is divided by parentheses 1 minus parentheses 1 plus that 4% over 12 again. And that plus parentheses has to be to the power negative 12 times 20. Close parentheses, close parentheses. Let's try it on the spreadsheet. So equals, I want to take my initial amount here times parentheses according to the formula, the APR divided by 12 months per year, so that's the periodic rate. Then that gets divided by parentheses 1 minus parentheses 1 plus, again, the periodic rate. So you're going to make that division. Close parentheses, raise it to the power on a spreadsheet. The caret key, that little hat, shift 6 is a power. Parentheses negative 12 times 20. So I can just point and click on those. Close the parentheses for the exponent, close the parentheses for the denominator, hit enter, and we should get the exact same number that the PMT formula gave us. I think the PMT formula is way easier to use. Other cool thing is once you've set this up once in a spreadsheet, you can just go change the numbers here. What if we had 500,000? What if the interest rate was 3.5%? What if we only needed it for 15 years? And it automatically updates everything. What's the monthly payment? What's the total amount in withdrawals? What's the total interest earned? Very cool. Thanks for playing.